Good afternoon, everyone. My name is Todd Migliori. I'm a director of software engineering at Comcast. I still like to think of myself as an architect, but truth be told, I spend far too much time in Excel these days to claim that anymore. Hopefully you guys don't hold that against me too much. Today I'm going to be talking to you about something we've built at Comcast called the Xfinity Service Platform. It's a bit of a journey talk. It's about enterprise transformation, legacy transformation, and cloud migration. So all in all, this has been a 3-year project for me. There's been lots of ups and lots of downs, but we're finally at the finish line, and I thought now would be a good time to come here and share some of the learnings that we've had over the past few years with the larger community. Hopefully you guys can take some of the things that we learned and take them back to your organizations and apply them to your projects. And hopefully that will help you to be as successful as we've been with this project. Let's start out and take a look at where we started circa 2015, about 3 years ago. We had this platform called the Enterprise Service Platform. It was pretty much your standard legacy SOA platform, lots of Oracle and WebLogic. Just to give you a brief overview of the platform, we were doing about 200 million transactions per day. We had 75 services, 15 different development teams, and over 150 consumers. So it was a pretty big platform within Comcast, but it was about 10 years old at this point, and it was really starting to show its age. We were struggling with a variety of different things. First and foremost is we were overly dependent on physical infrastructure. When we wanted to scale the platform, we couldn't scale it service by service. We had to scale the platform as a whole. And what that really amounted to is that whenever we wanted to scale out, we needed to deploy 10 new physical servers. And a lot of the challenge with that was a lot of times we actually had to procure the servers, get them shipped, get them racked and stacked in the data center, and then we would begin to build out our ESP footprint on that infrastructure. Unfortunately, this usually took between 60 and 90 days, right? So whenever it takes you 2 to 3 months to scale out one order of magnitude, you got some problems. The other area where we were having some issues was we had this concept of a shared release calendar. We had 15 different development teams, and they're all delivering features in accordance with one release calendar. And we only did deployments once a month, so we had about 12 deployments a year. So if the business came to you and they said, hey, we need this new feature, you essentially had to slot it into one of these 12 releases a year, or it wouldn't get deployed to production. And that really was kind of not where we wanted to be from an agility standpoint. The other issue we were having is we had this concept of auto manual deployments, I call them. We had lots of automation and stuff to do the releases, but there were still tons of manual steps in the process, and there was way too much overhead. So much so that it would take a team of ops engineers 2 hours to deploy all the services. And a lot of times they were doing it in the middle of the night off business hours to minimize the impact. The other issue we were having is we had a traditional L1, L2, and L3 support model, where the ops team was largely split out from the dev team and also the test team. There was lots of different handoffs, and more importantly, there was a lot of finger pointing whenever outages happened. It worked fine in dev, well, dev doesn't matter, that kind of stuff. The other big issue that we had was our data tier was, for the most part, active-passive, where we had our primary data store, the active one, on our East Coast data center, and we had a passive backup on our West Coast data center. And one of the biggest challenges there, whenever there were issues with the primary, we knew that the failover process took 60 minutes. So we would be on the outage, and everyone was really hesitant to initiate that failover protocol because that meant we were guaranteed to have a 60-minute outage. What usually happened is we would try and troubleshoot it for 60 minutes and then make the decision to fail it over, and it took another 60 minutes. So we had a 2-hour outage when we thought we were going to have a 2-minute outage. So that was a real challenge for us. All in all, we were just having stability issues all over the place. And when you look at this platform, it's kind of like the core of Comcast's back office. It really is involved in delivering all of our critical lines of business, everything from video to voice to data to some of our newer stuff like Xfinity Home and Xfinity Mobile. This is kind of like the core layer that enables all those different things. So it really needs to be highly available and resilient, and that's where we're having some major issues. So we were kind of, at this point, we were kind of stuck between a rock and a hard place, right? We couldn't just cap and grow and build new from the ground up because this platform was so critical to our business. We couldn't just scrap it and throw it out. It was too intertwined with all of our business lines. So what we had to do was come up with a way to transform it while it was still actively running our business, basically. And that was the biggest challenge we faced. So like all large enterprises do when faced with a big problem, we decided to have a summit. Right? We got all of our smartest folks in the room, and we set out trying to answer one question. That question was, how are we going to get out of this mess? So we realized at this point that we weren't going to be able to deliver features fast enough to keep up with the pace of the business on this legacy architecture. So we all got in the room together and we were kicking around different ideas, and then someone said, you know what we need to do? We need to migrate our apps to the cloud. So everybody's sort of looking at each other, nodding, yeah, that makes sense. We should do that, totally, right? That's gonna help with our resiliency. It's gonna help with our agility. Let's do that. And then, you know, one of the more pragmatic people in the room was like, how are we going to migrate this stuff to the cloud? It's heavyweight legacy WebLogic web services and monolithic Oracle RAC databases. Like these things you don't just pick them up and put them on the cloud and they work. So yeah, everybody's kind of looking around. They're like, you know what? That's a pretty good point too. That's a pretty good point. So, you know, someone else says, well, you know what we should do? We should build microservices. And we're like, you know what? Yeah. Some people are like, I just read an article about microservices. They sound great. Let's do that. So then we had to figure it out, right? We were going to build microservices and put them on the cloud, and that was going to solve all our problems. So then someone in the back of the room, probably an executive or something, raises his hand and he says, hey guys, what the hell is a microservice? Right? So everybody's like, that's not a bad question. What does it mean to be a microservice? What is it really all about? So then, you know, one of our really smart architects in the room raises his hand. He says, I know, guys. I know what a microservice is. It's a service. It's just really small. Like a microservice, right? So at this point in the meeting, I'm doing something similar to this. Not exactly. But in all seriousness, guys, this is one of the areas where we struggled the most. It's like, how do you define what it means to be a microservice and what's really important about a microservice? It's not just to be small. So I thought it would be good if I spent a few minutes talking to you about some of the characteristics of a microservice that we value at Comcast. It's true, yes, a microservice should be small, but how small? There's not really a magic number of lines of code or deployment service that says this is a microservice and that isn't, right? I would say that the real question you should ask yourself is not how small, but why should it be small, right? Like, why is it small? The reason we want it to be small is because the fact that it's small enables other things that we care about much more than just the sheer size of the service. First and foremost, a microservice should be agile. You should be able to build, test, and deploy it all the way up through production in a matter of minutes, not 30 days like we were doing before. A microservice should also be elastic. It should be able to auto-scale or push-button scale. And it should be able to do that in minutes also, not 60 or 90 days like we were doing before. A microservice should also be resilient. It should be able to survive traffic surges from upstream consumers And it should also be able to withstand latency from back-end dependencies and sometimes complete outages from back-end dependencies. A microservice should also be distributed. It should be distributed across multiple data centers and regions, and it should be able to automatically fail over from one site to the next with zero impact to your consumers. A microservice should also be event-driven, right? We want microservices to start using asynchronous interaction models. Microservices should be streaming data to and from each other. We want to get away from these traditional request-response-based interaction models. That's going to help out in a variety of ways with resiliency and performance and all sorts of other stuff. Another key to a microservice is it should be developed and run by a single team. This is all about DevOps. I'm a big believer in the efficiencies gained when you take away the silos from the different teams and you just have one team who's responsible to both build and run your apps. Another thing is a microservice should be singularly focused. You know, it's often said that a microservice should do one thing well. The difficult part is defining what one thing is. You know, one person might think accepting a payment is one thing, but in reality, that may involve 5 or 6 different service interactions. One of the rules of thumb I like to use when defining the one thing is if your service talks to more than one backend dependency, it's not a microservice. That's a clear way that you can decompose and split things out into separate services. But, you know, I think by and large, defining what that one thing is for your service is kind of like a case-by-case discussion you need to have with your team and decide what makes sense for you. And last but not least, a microservice should own its own data. Data access patterns are hugely important as we go to more and more of a distributed world. You can't have a situation where you have multiple services that are writing to the same piece of data. It's going to cause all sorts of consistency issues, and it's going to prevent your ability to continue to scale out to more and more sites. So that's really it, guys. In my opinion, these 8 things right here will tell you whether you're doing microservices or not. If you're doing these 8 things, I don't care whether you have a huge service or a small service, it's still a microservice. You could have the tiniest service in the world, and if it doesn't do these 8 things, I would argue that it's not a microservice. This next slide is about service decomposition strategies. You know, when you begin to move to a microservice-based architecture, you're going to start decomposing larger services into lots of small services. And the thing people don't always realize is as you do this decomposition, it introduces lots of additional complexity into your architecture, especially when you look at how consumers access those services. So what we have up here is kind of like how our app looked at the beginning. We had a couple of consumers talking to a couple of services, S1 and S2. This is obviously a simplification because we had over 150 consumers and 75 services, but I think you get the point. So now that we start decomposing the services, how does it look? We take S1 and we split it out into MS1, 2, and 3. We take S2, we split that out into MS4, 5, and 6. Now, we know the service is going to go away, so what does that look like? At this point, you're left with the question, how are we going to integrate these consumers with these services? So is it going to look something like this? I don't know about you guys, but that looks kind of complicated to me. So we didn't want to do this. So what we actually did at Comcast was something more like this, where we put an API gateway layer in between our consumers and our microservices. This is really nice because it gives you a single access point for all of your consumers to talk to your backend microservices. And you're also able to dynamically deploy whatever types of policies that you may want to deploy to all your microservices. And you can do it in one place versus doing it in all the different microservices. For instance, if I wanted to deploy a new security policy up there, you would have 2 choices. You would either have to add it to every service individually, or you can put it on the API gateway. So I guess the point I'm trying to make with this slide is that I think the API gateway is kind of essential as you go start to decompose services into many smaller services, because it keeps things clean and your consumers have that central point of access. Okay, this next slide here, there's a lot going on, but I think there's two key things I wanted to point out here, which I think are really important when you go to start building out a microservice architecture. The first and foremost has to do with consumer migration strategies. What we did was, as you can see in this orange layer right here, we had some networking load balancing technology where we built out some really sophisticated routing rules, which allowed us to seamlessly route consumers from the old platform to the new platform. And we were able to do it by consumer. We could also do it by service or service version. And that was pretty huge for us in a couple of areas. One thing it did for us was it allowed us to greatly reduce the migration time, because we didn't have to go running around to 150 consumers or 100 teams, 100 different applications and say, hey, we need you guys to make this change, we need you to make that change. We just updated some config in our routing layer, and it seamlessly moved traffic from the old to the new. The other key thing that it did for us was it greatly reduced the risk associated with the migration. We were able to cut traffic over to the new, and if something didn't look right or we saw an issue, we would just flip it back over to the old, basically unbeknownst to anyone else. So consumer migrations are pretty key when you look at migrating to microservice architecture. The other interesting thing on this slide is the concept of data decomposition. As you begin to decompose your services, you're also going to want to begin to decompose your data. What you can see here on the right is we have some legacy enterprise Oracle databases. And one of the difficulties we had there is all the services in the old architecture did writes to the same data, different services, and it caused all sorts of problems for us. So what we've done now is we took those legacy monolithic databases and we decomposed them into what I call micro data stores. And then we strapped data-driven microservices on top of those stores. And now we're able to control our writes much better, and we have much less issues with consistency and conflicts and things like that. This next slide is about platform consolidation. One of the big things we wanted to do with XSP was kind of consolidate a lot of the different mid-tier layers that we had at Comcast. I think when we started out, there were probably about 7 different mid-tiers. And the challenge was they were all doing very similar stuff. They were building services, yet they were all doing them in a very different way. I think each mid-tier basically had a totally different tech stack. If I was a developer in one of the mid-tiers and I needed a logging solution, I would build a logging framework. If James was a developer in a different mid-tier and he needed a logging solution, he would build a logging framework. And ultimately, we would end up with 7 different logging frameworks. So we had a lot of what we call undifferentiated heavy lifting, right? There was a lot of people solving the same problem different ways. And we thought it would make more sense if we solved the problem one way, and then all of the teams in the different mid-tiers would just leverage those tools and those frameworks. And that's really sort of what this XSP concept was all about. It was about building out a set of cloud-native microservice libraries on top of Cloud Foundry that all of our different mid-tier teams within Comcast could then leverage, so they didn't have to worry about non-functional stuff like logging and security and caching. And that freed them up to focus on actually building and delivering features, because they didn't have to worry about that undifferentiated heavy lifting we're talking about. So what we ended up with, and you can see this in this graphic I have here, is we had this single unified platform where Cloud Foundry was kind of the core at the center, and then we have this layer of XSP around it, which has all the cloud-native microservice libraries that we need. And then there's different layers, like this CMT layer is basically our domain-based microservices. The CTP layer above that does a lot of our sales and ordering orchestration. And the Convoy layer, I don't know, some of you guys may have heard Jason's talk earlier. The Convoy layer does a lot of our customer care orchestration on top of that. The other benefit of doing things this way is it enabled something I call team portability, where Now that everybody's used to doing things the same way and they're all familiar with the same frameworks, you can take a developer from one mid-tier team and just plop them in on the other one when priorities shift. Before, everybody was very specialized and it was hard to rotate people around teams. So this platform consolidation concept has been pretty huge for us also. The other thing that was kind of paramount for us as we were going through this transformation was resiliency. I think out of all the things we wanted to do, resiliency was probably at the top. Like I said earlier, we started out with this kind of active-passive architecture. Ultimately, what we were able to deliver was truly multi-site active-active architecture. And there were a couple of key things that we used to do that. First and foremost, we used Spring Boot actuator health check endpoints, and we had custom health checks configured for each service. And then we also fronted each of those services with a GSLB and configured it to do layer 7 health checks against that health check endpoint. So when the health check went red at one site, it would automatically fail over to the other site. So that sort of took care of things at the application layer for us. The other problem, probably the harder problem to solve, is how do we solve those problems at the data layer so we can also have active-active databases? And we did that through a combination of things. First and foremost, we used Golden Gate for some of our legacy Oracle databases. And then as we started to decompose those into those micro data stores, we started to move away from Oracle and onto things like Couchbase and Cassandra using XDCR and Couchbase rings, where we could distribute things across multiple sites. But at the end of the day, we were able to successfully build out this active-active architecture, and our impact minutes have gone way down, and our resiliency has gone through the roof. So this has been a big win for us also. All right, let's take a step back to the beginning, kind of look at where we were and compare and contrast with where we are now. So we started out with this thing called the Enterprise Services Platform. Then we built this other thing called Xfinity Service Platform. Just to give you an overview of where we're at with that, currently we're doing about 350 million transactions a day with that. We've got 200 services, 25 development teams, and over 200 consumers. We used to have this farm-based scalability model. Now we have push button and auto scaling. We used to have a shared release calendar. Now teams push releases at will. Many times we can do it in the middle of the day during business hours now. We used to have to do all of our deployments overnight when volumes were low and people wouldn't notice if there were blips in the radar. We used to have this concept of auto manual deployments. Now we have fully automated CD pipelines. They're able to take things from commit through all of our environments with fully automated tests and roll them out in production live during business hours. Most services pipelines run under 60 minutes, so this has been a huge step forward for us. The other thing is we went from the L1, L2, L3 support model to a full DevOps model. It might even be called DevTops because we have the testers in there as well. And a lot of times we're shifting, from having dedicated testing resources just to have the developers write the tests themselves. But we still do have some dedicated testers. The other thing is we went from the active-passive data model to multi-site active-active. Finally, we used to have lots of stability issues. Now we have true resiliency. So I'd like to sort of just quickly go through and summarize some of the key learnings that I hope you guys take away from this presentation and you're able to take those back to your orgs and try and implement some similar things. First and foremost, consumer migrations are key. I think out of all the stuff that we did for this project, the strategy that we came up with to migrate the consumers is what really made us successful because we weren't beholden to them to change anything at all. And when things went wrong, we were able to move them back very quickly where people, got comfortable with these migrations, where at the beginning there was a lot of people that weren't really sure whether it was going to work or not. And we proved to them through this migration strategy that, hey, we can do this seamlessly and there's going to be very little, if any, impact to you. The next thing is backwards compatibility is important. Again, this will prevent you from having to run around and chase different people down and get them to make changes. You're able to seamlessly migrate them from the old platform to the new. The more you can make things backwards compatible, the better off you will be. The next thing is to embrace DevOps. I think within our development teams, most of the developers really prefer this model. They like the end-to-end ownership and accountability that comes with the DevOps model. And I think what's a nice thing that happens once you do this is you start to develop full stack engineers versus having just development engineers or ops architects. The other thing is you need a strong platform team. The platform, whether you use Cloud Foundry or you have some other sort of platform as a service product, the platform is the core to everything. So if that doesn't run well, none of your other stuff is going to run well. Fortunately for us at Comcast, under Greg and Rob, we've got a really good platform team. So hats off to those guys. Sure, Greg. This one's key. So going back to that discussion about microservices and how small they need to be small enough so your services start fast, that's for sure. Because if the service starts fast, you'll be able to start to do things like auto scaling and being able to scale out in the middle of peak loads. But if they don't start fast enough, you'll notice that when you try to scale them with lots of traffic, you'll see spikes in response times and spikes in error rates. So you definitely want to be cognizant of that. The next thing is focus on data access patterns. Like I said before, as you continue to go to a more and more highly distributed environment, you really need to think about how you're integrating with your data, how you're accessing your data. You need to control your rights. You don't want any situations where multiple apps or multiple services are writing to the same data. And you want to try as much as possible to eliminate situations where you might have some legacy UI that writes to data and the service writes to data also. But by and large, you want to focus on your read should be fast and your write should be controlled. And then the last thing I wanted to just mention, Spring Boot rocks. I think all of our developers really like working with Spring Boot. It really is such a nice framework for developing these type of cloud native microservices, and it's been really great for us. So if you guys are considering starting to build microservices and you haven't looked at Spring Boot yet, I strongly recommend you do. And then last but not least, I just wanted to close up by offering some thanks to some folks from Comcast. First and foremost to the core team, the XSP core team. Those guys do most of the heavy lifting. A few of them are here, Jatin, Hari, and John somewhere. Yeah, like I said, these guys do all the heavy lifting. I just sort of point them in the right direction and let them go. Next is the Comcast platform team. Like I mentioned, Greg and Rob and Neville and Sergey and Tim and everybody else on that team. I think one of the reasons why we've been so successful is we have such a nice partnership with these guys. And we all get along, we all work well together. And I think that is really one of the reasons for the success. And I just want to say thanks for all your support, guys. I don't think we ever would have been as successful as we have been without having such a nice partnership with the platform team. And then last but not least, our friends at Pivotal and Accenture. So we didn't do all this stuff by ourselves. We had lots of help from people from Pivotal, like GT over there, and if Andrew's in the audience. We also work pretty closely with Accenture. I don't know if Vipul's here or Eric, but we definitely appreciate the collaboration with you guys, and it's been great working with you. One final thing, we've done a few talks already. I just wanted to give some shout outs. Tomorrow at 11:30, Tim Leong is going to be giving a talk. Nydia and Sheila are going to be giving a talk on Wednesday at 17:40. I'm not sure what time that is. Is that 5:40? 5:40, yeah. And then last but not least, Greg's going to be doing the keynote panel at 9 a.m. on Thursday. So that's it. Thanks, guys.